Hey everyone, welcome to the Drive Podcast. I'm your host, Peter Attia. Brian, thanks so much for staying up somewhat later, I guess, in the afternoon, evening, your time. It's really an honor to be able to speak with you here today about such an important topic. I think, as I told you when I reached out to you, this is certainly a subject matter I've paid very close attention to for a number of years, but I was still somewhat surprised by some of the revelations in your book. When I first read it, I actually had to read it a second time to fully assimilate all of it, at which point I reached out to you and said, look, I'd really love to speak with you, so I'm grateful for the time you've made. I'm sure this is a tale you tell often.
Well, thank you, Peter. Good to be here.
Let's just get right to the chase. Obviously, surveys of people around the world, certainly I can speak in the United States and the UK, a sizable portion of the population believe that autism is likely or probably caused by vaccines. Is that a fair statement today?
Yeah, it's a very well-known opinion. I don't know what the precise polling is at the moment, but yes, there's tended to be quite a strong view about that, particularly I think in North America, not so much in the UK at the moment, but yeah, I think that's true. A lot of people have this idea.
This is not something that you were paying enormous attention to initially. You were, I don't want to say a latecomer to this, but you weren't, I gather, paying close attention to this in the early 1990s or even earlier, because the idea itself that a vaccine could cause harm has certainly been around for probably more than 100 years, correct?
Sure. Yeah, different vaccines, yes, but the idea that it might cause autism arose in the late 1990s.
Mm-hmm.
Yeah.
So let's just talk about the story, because I think there is really there's a character that is at the center of this story, a character by the name of Andrew Wakefield, a former physician who, I have to be honest with you, I think prior to reading your book, the impression I had was that he was a misguided and not particularly competent physician. But I don't think I was aware of some of the other, shall we say, behaviors that would, I think, go beyond a lack of competence or scientific rigor.
On that point, it's an interesting point, because when I started researching the book, I mean, I'm reasonably experienced in the nature of storytelling for one reason or another. I've gone into it a little bit in my life, and I really wanted to try and have some kind of arc of development in this character. So I was looking to give him the benefit of the doubt in his early years. This is a guy who, as you say, he was a physician, or in fact he trained as a surgeon, and he went off from the UK to Canada in the late 1980s, where he studied at the Toronto General Hospital. And originally he was observing doctors there who were trying to do the world's first whole bowel transplant, and that was the idea they had at the time. And he was a trainee there, but he moved very quickly away from surgery, and we've never entirely found out the reason why he did that. Very unusual thing to do, because his mother told me that he'd always wanted to be a surgeon, nothing else but to be a surgeon. He moved away into research, and when I went back into those years, I really wanted to make him look believable, credible, almost heroic, because it's a better story. If you're trying to draw people in, they want something to latch onto. They want to get the idea that this was a good guy who, as you say, was misguided, was perhaps incompetent, perhaps moved away from the things that he really understood. But I never really was able to find anything that evidenced that. It seemed that at a very early stage, he demonstrated a fanatical obsession with proving that a particular infectious agent caused a particular issue. And nothing would shake him from the idea he latched onto. And the way he latched onto it was so extraordinary and so absurd that it was really very difficult to give him a good, positive, heroic, sympathetic start in the story.
Let's talk about his eureka moment, which, if I recall, was, oh, I don't know, it was on Young Street or Bathurst Street or something like that. It was in a pub drinking a Guinness. What was the amazing insight that he had in that pub in Toronto in the late '80s?
Well, what happened was, as you say, he the story which he told to another journalist. It's a remarkable piece of history because it never surfaced anywhere else other than an interview he did with another journalist. Um, was that he was, as I say, working at the Toronto General Hospital where they were uh, looking into the possibilities of whole bowel transplants. And the reason why one might want to do that is in order to deal with Crohn's disease. Most people, I think, have an idea of what Crohn's disease is: an appalling, ulcerating, blistering, burning disease of the bowels. Um, and nobody knows what causes it. Even today, nobody knows what causes it. People have got ideas, and there's been a lot of epidemiology, but I don't know if you've ever looked at it yourself, but the epidemiology of Crohn's disease is just totally baffling and bizarre. And no matter how many books you stack up on a table to try and understand it, you just realize it's just better to walk away and just believe it. Um, he was in this pub, is the way he tells it, and he wanted to find out what the cause of Crohn's disease was. And the mythology or the legend that he has sought to create is that he he didn't want to spend his life chopping out bits of gut, which is normally what happens if you get Crohn's disease. In addition to very heavy duty drug therapy, usually you end up having pieces of your gut chopped out. So he wanted to find out the cause as being a much more credible course in life. And I give him that credit at the start, and I set it up like that. He was trying to discover the cause of Crohn's disease. And he's looking into this pint of Guinness, and he says, well, the convention thinks to himself, well, the conventional wisdom is that Crohn's disease was caused by bacteria, food, some kind of allergic reaction inside the gut. And he came to the idea, well, maybe it isn't that. Maybe it was a disease of the blood supply to the gut wall, and an infectious agent. Now, this was in the late 1980s. This was when AIDS was really big in the news and really an intractable problem. And obviously, in the case of AIDS, they found an infectious agent. So he thought, well, what could the infectious agent be? And he came back to London and got a job at really, to be fair, at that time, a third-rate London medical school, the Royal Free in Hampstead, North London. And he was still on the budget of the Wellcome Trust, which at the time, today, the Wellcome Trust is a preeminent medicine and health-related charity, absolutely blue chip, gives out enormous sums of money, and really is, in many ways, the financial engine behind the United Kingdom's extraordinary success with, or apparent success with dealing with the coronavirus outbreak, because of the sequencing which is being carried out here on a massive scale, largely with funding that was originally given by the Wellcome Trust. But at the time, it was if you like, the grant-giving arm of a pharmaceutical company. And he was on their budget. And he came back to London, and he would be on their budget for a couple of years at this hospital and medical school, but he was going to inevitably be moved off their budget onto the budget of the medical school. So he's there, the clock's ticking, he's got this idea about Crohn's disease, and he goes to the hospital library, and takes out, or at least reads there, a 2-volume encyclopedia of viruses called Field's Virology. Big thing it is, couple of bricks thick in its 2 volumes, and starts going through it until he eventually comes to measles virus. And there he sees a paragraph which says that in in acute measles infection, the measles virus can be found in the gut, in the colon and the intestines generally. Now, and he thinks, and in Crohn's disease, this blistering that you get produces little ulcers, and measles, acute measles infection, characteristically, in fact, it's pathognomic, I think, of the disease. In measles, you get things called Koplik spots, which are little spots mostly in the mouth. And he came to the conclusion that these Koplik spots were essentially the same thing as was seen in the bowels when somebody has measles, usually a child. So he thinks, I found it. This is my eureka moment. Measles virus is the cause of Crohn's disease. Now, just as a little aside, the thing about fulminant measles is you can find it everywhere in the body. I mean, you wouldn't just find it in the gut, you wouldn't just find it in the mouth, you find it everywhere. I mean, for the period of acute infection, you can find measles all over. So nothing surprising that. But that's where he started off. And he then set about trying to prove that measles virus was the cause of Crohn's disease.
Now, if the measles virus is, in fact, the cause of Crohn's disease, and the measles virus is waning because of vaccination, is it safe to say then that the next leap is a vaccine that introduces a small amount of measles could still be causing a problem? Is that the next step?
Yeah, because the thing about Wakefield was that he could never do what he was. Because he wasn't a scientist, he wasn't trained in science. He trained as a surgeon, which has a particular psychology, I think. And I think, as I say in the book, in science, courage isn't about proving yourself right. It's in your efforts to prove yourself wrong. It's your efforts at a very early stage to try and refute your own hypothesis. So a hypothesis, which is nothing more than a guess. So you start off with a guess, and then you try and prove it wrong, rather than try and prove it right. Obviously, you're collecting data that supports it, but in order to work in a rational way, you try to prove yourself wrong. And he never got to that second stage at any time in his life. He never got to the stage of trying to question his own ideas, to doubt himself. And this, I think, many people came to regard as an extraordinary flaw of character, possibly for anybody, but certainly for scientists.
I'll just interject, Brian, with one of my favorite scientists who you can probably see behind me, Richard Feynman, very famous for having said, and I'm paraphrasing, that the first principle in science is not to be fooled, it's not to fool yourself, effectively. And you're absolutely right. When one comes up with a hypothesis, the goal is to do everything you can to demonstrate it is incorrect. And even the word proof in science is a loaded word, isn't it? Because unlike mathematics, we really don't have proofs in science. Everything is probabilistic, which I want to get to later. You look at a body of literature, a body of experiments, and you try to ascertain, perhaps just as a court would, what does the mountain of evidence suggest in one direction or another, versus, say, in science, relying on an anecdote or something like that. So, I couldn't agree with you more. And I think you're right, by the way. I trained as a surgeon, and I would go one step further and say this is not just about surgery. I just don't think medicine, the actual discipline of medicine, does a lot in the way of scientific training. So it is true that many people who train in medicine also go on to receive scientific training. But in speaking for myself, none of the scientific training I learned came from medical school. Medical school was really geared towards getting as many facts as possible into your head. You certainly learned a bit about the history of science. You were fortunate to put in context what other people had done and how we were able to utilize that information. But in terms of the scientific method and, this idea that you generate a hypothesis, you figure out what the right questions are to test it. You design experiments. You critically look for all the ways you could be fooled. That is very difficult to learn unless you spend time in a laboratory and you're well mentored. I actually never take offense to the idea when people say, doctors don't understand science, which is usually something that, someone with real scientific chops would level as a criticism.
Oh, I think that's right. So yes, so there he is, with this attempt to prove himself right. And I mean, as you say about medicine, I sometimes liken to like learning Chinese. The method essentially is that you read books and you sit in lecture halls and you see things. And if you ask a question, why is that so? Then the person who's teaching you will essentially say, because I say so. That's what it is. You just have to learn this stuff like a European learning Chinese. It's this is this symbol, this is this. Don't question it, just learn it. But the scientific method obviously is different now. But what Wakefield would do, and it's all over his work. I mean, it's everywhere. You find a particular word. It's almost his favorite word, and his favorite word was consistent. So he would say, this particular finding or this piece of data or whatever is consistent with his hypothesis. But of course, the thing about consistence, I mean, it is consistent that the orbit of Mercury is related to, I don't know, inflammatory bowel disease. It's consistent that Mercury rose this morning, and you could link any things together and say they're consistent. It's consistent with me talking to you.
Yeah, it's an even sillier word than associated with, which means nothing, right?
It means nothing. It means it's not a refutation. But he used this word consistent all the time and never stopped, and he never stopped to question at any stage or carry out any kind of experiment or research or anything that would conflict with that commitment to the idea at this stage that measles virus was the cause of Crohn's disease. And when anybody else came up with contrary information, so for example, he would say, and this is one I don't have a background in medicine or science. I had to learn it all from nothing to do this work. And he would use, for example, a technology called immunohistochemistry. It's a chemical, essentially a chemical staining, a microscopic staining technique. And so you take bits of tissue out the gut, and you prepare it and you stain it and with certain things, and use certain antibodies and what have you, and you look down a microscope, and if the thing that you're looking for, in this case it would be measles, you'll see a stain, a change in a color in the stain. It's usually brown. So this is a microscopic technique. But then other centers around the world, other universities in Japan and in the United States and in the UK, people used what is now, probably everybody knows what it is now, PCR, the polymerase chain reaction, which is now big news all over because of the efforts to tackle the coronavirus. When people used this molecular method, they couldn't find the measles virus, or where they did and anyway, I won't go into the whole detail. They couldn't find the measles virus. Now, I once was giving a talk. I can't remember where it was. It was somewhere in the States. I can't remember. It was a lab meeting with biology students. So they were like about 18 or something like that. And I said that he'd found measles virus using immunohistochemistry. Other people used the polymerase chain reaction. And Wakefield's answer to that was that the PCR wasn't sensitive enough. At which point, to my initial surprise, my audience laughed. And I didn't realize that it was that funny. I mean, I realized it was rather paradoxical to suggest you could find something under a microscope that you cannot find at a molecular level. But that was the lengths that Wakefield would go to stick with his hypothesis that measles virus was the cause of Crohn's
And
disease.
let's put that in context, Brian. So in 1993, I believe, is when he first published that paper in the Journal of Virology. Is that correct? Using his immunohistochemistry.
Journal of Medical
Yeah,
Virology, yeah.
JMed Viral, right. And he published in there saying, we've identified this using immunohistochemistry. And as you said, it was 2 years later that a Japanese group using PCR said, we cannot replicate these results under any circumstance. Do you have a sense what the scientific community thought at that time? First of all, it's not impossible for scientific results to conflict, but was it just sort of dismissed as, well, maybe there was an artifact, maybe there was a contamination, maybe this person didn't understand how to do the assay correctly, maybe their controls weren't right. What was the view of how, because remember, I'm not telling you to remember this, I'm saying just for the listener, like, science is about advancing knowledge. It's about being at the edge of what is known and unknown and trying to advance that. And this is a potentially interesting hypothesis, right? Let's acknowledge that if measles is the cause of Crohn's disease, this would be a very important thing to know. Yeah. So I'm just sort of curious, in hindsight or retrospect, in the mid 90s, when PCR, which at that point was becoming the way that you would do this type of assay, so now the gold standard, for the reasons that I think we'll get into later on, because I want to get into O'Leary's lab and really understand how one can be fooled.
I think that's the most interesting part of the whole thing for me. But anyway,
yeah. So, I mean, did you get a sense of how the scientific community viewed Wakefield's work at that time, prior to 1998? Because when we get to 98, it's a whole other ball of wax.
Well, when you say the scientific community, first you've got to remember that this is a fairly specialist field. So there wouldn't be a lot of people watching this thing too carefully.
Even outside of gastroenterology? I mean, sorry, within gastroenterology, I'm sorry.
Yeah, within gastroenterology, people would pay a little bit of attention to it, but it's a very specialist. It's probably quite a small community of scientists who are working in this area, and I think they mostly all know each other. They all go to the same drug industry sponsored conferences, but within that, there were people who thought that he was incompetent because it appeared that he'd been using inappropriate controls in his work, because his work, that his microscopic work, looking at stains under a microscope, involved controls. So people were saying, well, how is he getting these results with controls? Because you would expect to see, if he was using the technique wrongly, you would expect it to show up in not only in the specimens, but also the controls, if it was contamination or something like that. He was claiming to use controls, and some people thought he was incompetent. But there were other people, and I could name, and I don't think he would mind me naming him, a professor in London called Tom MacDonald. He's now the Dean of Research at a medical centre where the Queen's husband is currently resident as we speak. And he was of the view, even then, that Wakefield's work was fraudulent, that he was concocting results even then. And that created a problem for me, as I was saying earlier, because I wanted to paint Wakefield in the best possible light. So I never really, in the book, went too much into that, because I suppose, to be authorial about it, I didn't want to piss on my own bonfire. I mean, I didn't want to lead people from the get-go to suspect that he was doing what he came to be shown to be doing elsewhere. So I kind of glossed over that a little bit. But there were people even then who said that his work was fraudulent. And in fact, Professor MacDonald declined to go when he was part of a team at another London hospital who moved to where Wakefield was going to work, or was working, in Hampstead, North London, and he refused to go. He took a much less interesting, and I don't know whether it was a better paid or worse paid job, way away from 100 miles or so away from London, rather than go and work in a place where Wakefield was. So there was no clear consensus as what explained how it could be that Wakefield would find these things by microscopic techniques. In fact, he said that he'd seen the virus under a microscope.
Which I think it's important to explain to people that that's not possible.
Well, anyway, that was the claim in the paper. That was the claim.
Was this an electron? Was this electron?
An electron.
Oh, I'm sorry. I thought you meant light microscopy. Okay.
No, when we get to him seeing it, it was an electron microscope, and ultimately that came apart. The wheels came off that one as well. But that was the idea. But so there was this confusion, and medicine, as I certainly found this as I went on through my inquiries. Doctors, I think, and perhaps professionals generally, are very reluctant to come to the conclusion that somebody is dishonest as opposed to wrong. Dishonesty inevitably requires the intent to deceive or intent to mislead. People are very reluctant to come to that conclusion. And that's understandable. You want to give people the benefit of the doubt. So the world just kind of moved on and accepted that there was this doctor with a little team of people he was trying to gather together in London who maintained that measles virus was the cause of Crohn's disease in the face of really very compelling evidence from multiple centres that in Crohn's disease, measles was not a causal factor. Wakefield just dismissed these other centres and said they didn't know what they were doing, but he did. They were looking in the wrong place, or the virus was present at levels below the threshold of detection by PCR, but not below the level of detection by microscopic immunohistochemistry techniques, which in itself...
I'm trying to think of an analogy, because obviously I've done both of these techniques personally, and there are people listening to this who have spent time in a laboratory that will understand how ridiculous and absurd that statement is. But I appreciate that most people don't, and I'm trying to think of an analogy. It's sort of like saying, I can see the details on the moon with my naked eye, but I can't see them with the most high-powered telescope because the resolution isn't good enough.
It's not a good telescope, or you don't know how to use it properly.
It's not a good enough telescope lens, so that's why I can't see what's on the moon. That's why you can't see what's there, but I can see it with my naked eye. I mean, that's how absurd that claim is. So,
yeah, that's why I say undergraduate biology students laughed when I was really interested. I used it ever since. They laughed.
So let's fast forward a few years now into a place where his thesis undergoes a change, right? A new layer is added to this, and it becomes effectively the main story that you are writing about, which is a very famous paper that came out in 1998 in a very famous and highly regarded journal called the Lancet, which would probably rank in the top 5 in the world scientifically. So let's talk a little bit about that paper, which I have to admit, I don't think at the time I realized how pathetic it was. In other words, it's a very poorly done report on 12 patients, not recruited at random. I mean, you're going to go through all of this, but it's almost amazing, not almost, it's outright amazing that the Lancet published it in the first place, let alone took so long to basically pull it. But let's talk about what it is that took Wakefield down this new path to perhaps an even bigger discovery or idea.
Right. So after he came up with this idea about measles virus causing Crohn's disease, one criticism that was leveled was that, well, you say that measles virus is causing Crohn's disease, but at the time, which is not true now, but at the time, the incidence of Crohn's disease was rising and measles was in decline because of the advent of vaccination. So the vaccine itself, he realized, I don't know whether he needed an encyclopedia to tell him this, but he realized contained live measles virus. So he modified his theory, his hypothesis at that stage, to encompass vaccines causing Crohn's disease. So there he was saying that vaccines were linked to Crohn's disease. And this drew him to the attention of somebody else, a man named Richard Barr. And Richard Barr was an obscure lawyer, an office working lawyer, which we in the UK call a solicitor, in Eastern England, in a small provincial town in Eastern England, doing humdrum work, magistrates' courts, petty offenders writing wills, things like that, house conveyancing. And he was, in fact, a specialist written a book about it on house conveyancing, this man, Richard Barr. And as I explained in the book, so I won't go into now in massive detail, he got a contract with the British government agency to try to show that the MMR vaccine, the measles, mumps, and rubella vaccine, was the cause of developmental issues, particularly autism, and how Richard Barr descended on autism, picked autism out of a whole cluster of other things, is a story in itself. This man, Richard Barr, was looking to find a doctor who would help him, would agree with him that vaccines caused, ultimately, they settled on autism. And his problem was there weren't any in the UK who really took that position at all. It was such an out to the left kind of idea that he couldn't find anybody of the remotest credibility to advance that hypothesis. And without an quote unquote expert to say, yes, I say that there's a probable cause that measles in the MMR causes autism, he ended up going to this man, a bowel surgeon, trained as a bowel surgeon, whose subject was Crohn's disease and whose whole theory was about measles causing Crohn's disease. He hired him, this lawyer hired him. This was in early 1996, after some talks between them beforehand. So there Wakefield was now hired by a lawyer at very generous hourly rates to help make a case that the measles vaccine in MMR caused autism. Now, this was interesting, not least because Wakefield knew nothing about autism and he knew nothing about vaccines. Neither of these were any part of his training, any part of his professional expertise, but he was the best that this man, Richard Barr, could get. So together, they set about trying to prove that the MMR vaccine caused autism. It's a long story as to why they picked autism, but they did. This lawyer picked autism. Long story about why that was. Very interesting, and in many ways, I wish I'd gone into it more. But
do you want to just give sort of a short overview of it?
Well, it was essentially that this man Richard Barr latched on to another player in all this, which was a woman called Jackie Fletcher, and Jackie Fletcher had a child who, within a couple of weeks of receiving his MMR shot, started having seizures and went on to show serious neurological illness, transformative lifelong damage, or damage presupposes that and she had seen media coverage of an issue to do with vaccines, and while she was in the hospital talking to other parents, one of them or some other of them gave her the idea that vaccines could cause this injury to her child. Now, her child didn't have autism. I hate using the word retarded, but I mean, specialists used it, so I suppose I can. She had a profoundly retarded and handicapped child Um, and she came to believe that the cause was the vaccine, nothing to do with autism. So in order for her to sue in the United Kingdom, she had to get lots and lots of other people to say the same thing, because the only place you could ever get money to do that was a government scheme where they provided money for people who couldn't afford to sue. And who can afford to sue? Drug companies or vaccine manufacturers. So they kind of, she got together with this lawyer, Richard Barr, and with Wakefield, and together they made music over this idea that the MMR vaccine caused autism. It was generated basically because autism, which although the phenomenon, the manifestations of what came to be called autism have been present, you could go back to like the Victorian lunatic asylums in the United Kingdom, and you would see autism. And there, I've got video in from television programs long before MMR was even licensed, which you would say, well, in that period, you would say that was autism. Autism had come to be constructed. What a lot of people don't realize about autism is that autism is a construct. There's no, it's not like, let me think of an example. It's not like Crohn's disease. Autism is a kind of tick box diagnosis of different signs and symptoms which are brought together and clustered together. And it's really been created, a bit like schizophrenia, really. And in fact, schizophrenia kind of went into decline with the rise of autism. A bit like childhood schizophrenia, autism was an emerging diagnosis in the early 1990s. And in fact, the American Medical Association, the World Health Organization, both brought out diagnostic categories in the early 1990s, identifying a spectrum of disorders, one of which was autism, and there were several others. So this was something which, when this Jackie Fletcher, this woman running this, she's running this effort to sue for her own child, she set up a group and they started doing surveys. And in those surveys, they came up with quite a few cases of autism because it was beginning to be diagnosed. And so they kind of said, okay, well, that's the most common diagnosis we can cluster together. So we'll go after that. So that's why they went after MMR and autism. Simply the artifactual situation of there being a newly emergent diagnostic category, and also the introduction in the UK of the MMR vaccine. So they went after this idea, and Wakefield was then enlisted. So Richard Barr provided what initially was most important, was the money for Wakefield to do research. And so what they did is they made a grant application, very similar to any scientific researcher who wants to look into something. You make a grant application to somebody who's got some money. And the people who had the money were this government agency. It was actually called the Legal Aid Board, operating a thing called the Legal Aid Fund, which funded people who couldn't afford to sue drug companies to sue the manufacturers of MMR. So Wakefield had the job of ensuring that this lawsuit was launched. At the time, the lawsuit hadn't been launched. It had just been collecting clients, collecting anecdotes, collecting stories, taking statements and preparing so that this government agency would fund them to go forward and sue the drug companies. So that was Wakefield's mission, and they made the grant application to the Legal Aid Board in June of 1996. Now, the paper we're getting to that you mentioned was published in February 1998. So this scheme between these people, and there were a couple of other people involved in it as well, was the origins of the idea that vaccines caused autism. And ultimately, we would find this was the origins, the acorn, if you like, from which the anti-vaccine movement, even of today, emerged to create the issues they're creating over the coronavirus shots. So that was the explanation in very sketched out terms of why they hired Wakefield. Richard Barr was going to get the money from the legal board. Jackie Fletcher, this woman, she started an organization which she gave the name of Jabs to. She would bring the clients, she would recruit the clients, and Wakefield would do the tests that were going to show that the MMR vaccine was the cause of autism. In fact, the proposal he put to the legal aid board with this solicitor Richard Barr said in advance of a single child in this paper, the 12-child paper which you mentioned, before a single one of those children had been investigated at that hospital, they had made the proposal to the legal aid board that they would show that there was a new syndrome which included both inflammatory bowel disease, which was what interested Wakefield, and autism, which interested the lawyer and Jackie Fletcher, the campaigner. And they bolted it all together, made a grant application, and a duty lawyer in the government's legal aid board, a woman, she was in her late 20s, ultimately signed the document for Wakefield to be employed to do research that ultimately was what ended up in the Lancet 18 months or so, year and a half later, in this paper that created this enormous furore. And what nobody knew until, well, I came along, I suppose I have to say that, although everyone criticizes me now, particularly doctors who sort of say, oh, he's self-aggrandizing. And they do things like saying, no, I actually did one at my publisher's university, Johns Hopkins, the other day. And somebody said, some of the people around said, oh, well, you helped to unmask this. I said, well, no, I didn't help it. I did it. And that's one of the extraordinary things about this story, that the medical establishment just kind of sat back and let all this go on. And it appeared that only a journalist spotted the grounds to believe there was something funny going on here. But anyway, so this was the background to this paper. And then in February 1998, I'm sorry to talk so long, but anyway, in February 1998, this paper was published in the Lancet, which in terms of general medicine, I would say was the number 2 journal after the New England Journal of Medicine. It's way down the rankings from Nature and Science, but they're general science journals, so they carry a lot of other stuff other than medicine. When you get into general medicine, it goes New England Journal of Medicine, the Lancet, which kind of has a bit of a tussle with the Journal of the American Medical Association, Annals of Internal Medicine. Then you get to the British Medical Journal, and onward down you go. So very prestigious journal, a 12-child case series. And you said, Peter, earlier that, I'll shut up in a moment, but you said earlier that this was a ropey paper and so on and so forth. I don't agree with that, actually. At face value, it's kind of with the knowledge of hindsight. Once you know the story, you look at that paper and you say, well, this is all a joke. And yeah, but at the time, it was very credible because it was a case series. Now, when you think about case series, it's literally a collection of anecdotes. So, for example, Crohn's disease, when that was discovered in the it wasn't discovered, but when it was formally characterized in the 1930s, fully described, that was a case series of tissue samples taken from 14 patients. Autism itself, which was first characterized and properly described, in fact, from Johns Hopkins University, publishers of my book, on 11 children. It was a case series of 11 children. AIDS, what came to be known as AIDS, was first classically described in 1981, based on 5 gay men in Los Angeles. So there's nothing questionable or improper or inadequate about a case series of 12 children.
Yeah, I think what I was referring to is something we'll get to later. So it's less the size of it. And I think, if my memory serves me correctly, Brian, there was not an institutional review board that had approved what those children went through.
Well, the paper said there was.
I see. But that turned out to be incorrect. Is that?
Turned out to be a lie. It was a lie. See, what interest, just as kind of a brief aside, a lot of people think I'm like, a pro-vaccine campaigner. And I think you probably think this, and I'm not. And that is not what got me involved in this in the first place. What got me involved in this in the first place was to do with the scientific method. How did this paper how did this paper work? What was going on behind it? And one of the things that really bugs me is people who believe they can judge research by a text on a piece of paper or on a screen. And you can't. Those papers are not even the study. People use, I'm sure you're aware of this, that the people use the word study and paper interchangeably. And they believe that the paper is what it's all about. And what I was able to do, and I still believe, I believe it, nobody's ever done it. I don't think, but certainly no journalist has ever done it. I've been asking since last year publicly if anybody knows somebody who's done anything similar, I'd like to know about it because it would be interesting and I'd incorporate it into the story, to go around the back of the paper and find out who the patients were, what was wrong with them, what was their diagnoses, what was their histories, what were their test results, and all of that. And I did it on these 12 children.
So let's talk about it, because it's so powerful. And as you said, if this is the acorn of the movement, we have to resort to the long and arid dissertations, as Bastiat said, and really understand that. So let's start with a fundamental question of how were these subjects recruited?
Right. Well, at face value, they appeared just to be part of the routine caseload of this hospital's bowel clinic, a pediatric bowel clinic. And essentially, the picture was this. Over a period between, over a period of about maximum 6 to 9 months, a series of parents turned up with their children at this bowel clinic in the hospital, a pediatric bowel clinic. And they said, words to the effect of, my child was developing perfectly normally, perfectly happy child. 11 of these children were boys, one was a girl. All of them were white. My child was developing perfectly normally. We gave him, or in one case her, the MMR, took him to the doctor, got the MMR, and within days, specifically within 14 days, that was the range, that was the maximum range that they allegedly reported, within 14 days, and one of them was said to have come on immediately after the vaccine. So between immediately and 14 days, 8 out of these 12 the parents of, I have to express it carefully because 2 of the children were brothers. So I have to say the parents of 8 of the 12 children said that the first symptoms of their child's developmental issue, autism overwhelmingly, came on within 14 days of an MMR shot. And at face value, if that was true, then that could be potentially the first snapshot of a hidden epidemic of catastrophic injuries to children. It may be that these doctors at this hospital were just better doctors, more thorough, asked more questions, had just more time or whatever, and that possibly all over the world children were experiencing this and just nobody had noticed. So the fact that this paper said these things was extraordinary in itself, and it got network coverage right across the spectrum that night. The UK then had 5 national networks, and they all carried it on the evening news, very substantial media coverage, because the hospital and medical school convened a press conference, which was chaired by the dean of the medical school. And one of the people on the platform, the table anyway, with Wakefield was a professor of gastroenterology, the man who in fact had hired Wakefield from Canada. So the media thought, well, this must be something important, and it had been trailed in advance. There had been leaks and promotional things that had been done to attract more and more attention to this thing. They absolutely knew what they were doing. Extra phone lines, extra landlines were installed in the hospital. This is back in the day of mechanical answering machines. They went out and bought mechanical answering machines to field the public alarm that they knew they were going to create. And this hospital, this medical school, and this Andrew Wakefield announced to the world their probable cause of autism as the MMR vaccine. And of course, the result would be obvious, and it was.
Tell people what actually what those kids went through when they were enrolled in a study that, as we would later learn, did not even have an IRB to approve it. What was the actual set of procedures that these children went through?
Well, it was described in advance. This is very interesting too. It was described in advance to the legal board, to the funding agency to which they'd made this grant application to do this work, as the so first I should say these children are children who don't like their lives being disrupted. These are kind of children who the slightest variation in some cases to their routine will cause them great distress. It's one of the curiosities of autism. Um, so they were brought to London. None of them lived in London. The nearest family was 60 miles away. Some were 280 miles away.
And one was in the United States.
Yeah, one was on the island of Jersey in the English Channel near France, and one was from the Bay Area of California.
And just to hit pause for a second, that immediately speaks to the idea that these weren't just kids being seen in this hospital as part of the routine caseload, but let's put that aside for a moment.
Yeah, I mean the idea that you would bring somebody from the Bay Area of California to London for medical treatment is particularly that hospital is absurd. The idea that there aren't good hospitals in San Francisco or California generally is an absurdity. So that in itself, interestingly enough, that child was well, only won't go into that. It's like that's I'm going to.
But yes, back to your point. We're talking about children who any disruption of routine is traumatic, and so we're going to bring these kids here. And what was done to them?
Okay, so the children were brought in on a Sunday, different Sundays. They didn't all turn up at the same time. Different Sundays. On Sunday afternoon, they would turn up. A doctor would take their histories from the parents. So the parent would simply be interviewed as to what they could remember. The child would be examined. They would then be bowel prepped for colonoscopy. In fact, it was an ileocolonoscopy. I mean, I've had a colonoscopy, but I've never had an ileocolonoscopy. In a colonoscopy, you go in, I don't need to tell you, but there might be a few people who, might just need the route map. You go in through the anus, you come up through the sigmoid colon, you come up the descending colon, you cross at the splenic flexure, across the transverse colon, which sort of sags across behind the breastbone. You turn at the hepatic flexure, you go down the ascending colon to the cecum, which is pretty much where the appendix is. And then there's a valve there. So that's a colonoscopy to do that. Then there's a valve, a little valve. And if you go through that valve separates the large bowel, the colon, from the small bowel. And that particular stretch of the small bowel is called the ileum. And the first couple of centimeters of that is accessible to an instrument, a colonoscope or endoscope, if you like. And you can get into the first 2 centimeters. And the thing is, when you go past that valve into the small intestine is the bit that takes nutrients out of food. It's actually prior to the colon. So from your mouth, this is the top end rather than the bottom or the distal end. So you get into the distal end of the small intestine. The small intestine is what takes nutrition out of food. And the large bowel more or less takes water out of your feces so that we don't trail stuff around behind us. Well, for most of our lives anyway. So this instrument would go up, round, down, and then there was quite a difficult maneuver to get into the small intestine. It's quite a significant piece of work in itself. And in fact, later, not actually one of the 12, but later in the series, a child had catastrophic damage caused to him by this procedure, and there was a huge financial settlement from the hospital. But anyway, so that was the first thing they do. Some of them also had upper endoscopies where you push a tube down the throat and look around, mostly in the duodenum and that area. So that would be the first thing that would happen the next day. And then most of the children had lumbar punctures, spinal taps, which is a needle basically pushed into the spine to take fluid, essentially brain fluid, through the spine. They were required to undergo MRI scans, um, EEGs, electroencephalograms, um, and let me think what else. Barium meals, where you're essentially X-rayed. You drink a radioactive drink, and you're X-rayed to get an image of the gut. Blood tests, which generally required with these kids 3 people to hold them down. In fact, Andrew Wakefield sued me over some of this. We maybe get to that at some point. He sued me, and one of the things he sued me over was saying that these children were being held down by 3 people. In fact, yes, they were. There were children screaming. One child collapsed 3 times in the corridor. 2 children one had to be admitted to another hospital after discharge from the Royal Free for apparent side effects or consequences of lumbar puncture. Another one had an emergency doctor called to their home. So they had that. They had blood tests. And what else did they have? I've probably forgotten something.
And some of these children were so constipated upon arrival that, if I recall, the colonoscopies were very difficult colonoscopies. They did not have easy bowel preps the way, a child might. The irony, of course, is that most of these kids were anything but having inflammatory bowel disease or Crohn's disease, given the incredible constipation that many of them experienced.
You can have constipation with inflammatory bowel disease, but it's unusual, and it's usually part of the differential diagnosis that the patient doesn't have inflammatory bowel disease. And they also had blood tests. In fact, the clinicians working on this had themselves I wouldn't say devised, but had published on a panel of blood tests which they used to do, which determined whether or not there was a probable cause to do colonoscopies, or ileocolonoscopies in this case. And those blood tests all came back normal. But they still went ahead and did it anyway, because Wakefield had said to them, which is part of his contract with the legal board to help sue vaccine manufacturers, that there might be some lesser inflammation that wasn't being picked up by the blood test, just like with the measles virus not being detected by the PCR because the PCR wasn't sensitive enough. So the blood tests weren't sensitive enough to detect the bowel disease that he said these children had, or suspected they had. In fact, he told the legal aid board that they did have it before he did the research, which purportedly discovered it. But anyway, that's just the way these things go in this story.
So how does John O'Leary enter the story? Because he becomes a very important collaborator, as effectively doing the most important pathology here, correct?
Yeah. So what Wakefield was trying to do, the reason why he wanted these tests done, was that he was looking for measles virus. So if your hypothesis is that measles virus causes Crohn's disease or causes autism or whatever, well, those 2 things. The thing about the last part of the small intestine, the ileum, that is the most characteristic part of the bowel where Crohn's disease is found. Crohn's disease can manifest anywhere between the mouth and the anus. In fact, it can. But where it most characteristically manifests is exactly where they went to. And this got Wakefield really excited. So what he wanted to do was to get into the small intestines of these children in order to find the measles virus. Because if you found measles virus live long after vaccination, we're talking about it persisting years after vaccination. Some of these kids were aged 9. Some of them were, the youngest was 3, the oldest was 9.5. So you're talking about children who would have been vaccinated years previously. And his hypothesis was that the measles virus was persisting in the small intestine, and he was going to find it. So when the endoscopist, so basically when you do a colonoscopy, you go all the way in without doing very much. You just try and get in. And as you say, some of these children were so constipated they couldn't get in and actually had to abandon the thing and clean them out again. And then one child, they said they were going to do it 3 times until the mother said, no more of this. But so he wanted to find the measles virus in the small intestine. So when the endoscopist got as far as the small intestine, he then man came named Simon Murch did some of it, and another guy called Mike Thompson did some of it. Um, they would take little biopsy snips. They would snip off on the end of the colonoscope. They got little jaws, and they would snip off a bit of tissue and bring it back through the thing. There'd be a nurse standing to one side who would like be pulling these things back through little rods down the tube, and then the colonoscope would come back through the gut, taking little bits of tissue at each of the points at the ascending colon, at the transverse colon, at the descending colon, in the sigmoid colon, at the rectum, but the gold in this for Wakefield was in the small intestine, and so in the waiting in the endoscopy suite where this went on, there was a scientist who was actually a PhD. He was doing his PhD, working under Wakefield's direction, waiting to take samples of the tissue away and freeze it in liquid nitrogen so that it could be tested using the polymerase chain reaction for measles virus. And yes, this scientist did this way. In fact, his PhD was a very good piece of work. It's not like a PhD in the arts. I mean, where you can, well, I think in the arts sometimes you get a PhD just for turning up and writing the thing. But he actually did a bit of science, and he developed a gold standard PCR test for measles virus, and Wakefield supervised that, and they published on that, and then they went on in Wakefield's own lab to use the PCR technique to identify measles virus, and they couldn't find measles virus in any of these children. And Wakefield's answer to that was, oh, the PCR wasn't sensitive enough.
And why had he switched to PCR here as opposed to going back to the immunohistochemistry? Because he had already made this criticism in 95 when the Japanese group said, using PCR, we can't find it. And he had previously in 93 said, oh, no, it's here with immunohistochemistry. So why in 98 is he not going back to immunohistochemistry?
That's a good question. I like your questions. I mean, I don't normally get doctors doing these conversations, so nobody asked that. It's a very good question. The reason why he wanted to do PCR and had to do PCR was in the grant application to the British government's legal aid board, he'd said up front in years before, 18 months before the paper was written and before any of these children had been investigated in the hospital, that they would undergo PCR for strain-specific sequencing. And I think probably everyone who's got a television set or radio these days knows what that means, because it's so part of the discussion over vaccines. So he wanted to show that this virus came from a vaccine, because the measles virus could come from there could be three possibilities. One, it's a virus that comes from nature. You caught it from somebody. One is that it's a laboratory strain, because there are particular strains of the virus which are kept for laboratory work. And the other is it came from a vaccine. But in order to determine which one it was, you couldn't use immunohistochemistry, because it wouldn't get you down to the nucleotides, which is what you need to get down to in order to sequence. It's classic procedures, absolute workhorse procedure.
I mean, maybe to just explain to people, immunohistochemistry might have the ability to recognize there's a person there. PCR can fingerprint the person. And this is sort of like saying there are three people, and I just need to see which fingerprint it is to know if it's the lab strain, which would be a contamination if it showed up in your sample, a naturally occurring strain, so it's a transmission that you acquired, versus a vaccine strain.
Yeah. Yeah,
and he was trying to demonstrate and test the hypothesis. If we're going to continue to give him the benefit of the doubt at this point, he was testing a hypothesis that said...
Yeah, I'd have to take issue with your use of the word testing. He wasn't testing a hypothesis. He was advancing it and simply trying to prove that it was so. He at no stage did what a scientist would do, which would be to test it by attempting to falsify it, try and find some reason to believe that he was wrong. He simply wanted to prove that he was right, and he'd set out what it was he was going to find in his grant application before a single one of these children went anywhere near the hospital.
This is a totally random aside, but I remember you made the point about the relative lack of rigor that went into his grant application. It wasn't like he was applying through the most rigorous or applying to the most rigorous granting entity. And it actually reminds me of the first grant application I ever wrote in my life, which was in medical school for a very small project. It was for a summer research project. And at my medical school, they had this amazing thing where you could get paid an enormous sum of money to do research for a summer. It was basically a great way to offset your tuition. It amounted to about a third of your tuition for the year. And so I put my little application together, and I just happened to review it with a guy named Pat Brown, who's a very famous scientist at Stanford. And I must say, I have to hand it to him. He just schooled me on what it means to write a scientific proposal. And he didn't pull any punches with how pathetic it was. And part of it was, this lack of, at the time, understanding. I was a first-year medical student. I really didn't understand what it meant to have a hypothesis, generate a series of questions, and go through this process we're describing. And I had to go back to the drawing board and start all over again. And I bet that if someone like a Pat Brown were to take a look at the proposal put forth by Wakefield, they would have had the same reaction, which is, this is not a person who has the chops to do this type of investigation. And again, I think it speaks to another point you made, which is the relative lack of policing in the field. And by policing, I don't mean literal policing, but I mean self-auditing and self-policing.
Yes, I mean the grant application he put in was received by somebody with no medical background and no medical or scientific advice or contrary opinion or anything was sought by the funding agency. It was literally a young lawyer with no background in science, who simply authorized the work.
So after Wakefield and his colleague cannot find any evidence of the measles virus, either naturally occurring or through vaccine, in the distal ileum via PCR, in theory, that should be the end of this inquiry at this point in time. But what happens next?
Well, so what he did was, using public money, he flew to New York and found an Irish professor who was then doing teaching in New York, and asked him if he could use his PCR equipment. This professor, man named John O'Leary, was going back to Ireland, back to Dublin, to work at a hospital, the Coombe Women's Hospital. It was a maternity hospital, not exactly a great centre of scientific inquiry, but he was going back there, and he said to Wakefield, yes, I can find whatever you need to find, and then proceeded to set about trying to find measles virus in bowel tissues taken from children at the Royal Free Hospital in Hampstead in North London. And he was paid an enormous amount of public money to do this. And he ultimately, from his lab, they published a paper claiming that they'd found measles virus in nearly all the children that Wakefield's had sent samples from.
Now, I think to really explain what happened in O'Leary's lab, one has to understand a little bit about PCR and what the number of cycles mean, what amplification means, and ultimately we'll even talk a little bit about the controls. And again, I don't ask this of you lightly, because I know that these are technical topics. But again, if one truly wants to understand what took place, I think one has to understand what took place in O'Leary's lab, because in many ways that is the epicenter. In my opinion, maybe you would interpret the facts differently, and I would respect your opinion more than my own. But I almost view O'Leary's lab as the epicenter of the fraud.
I agree with you. I mean, I agree with you, and I agree, and I appreciate the point you're making, because you would not believe how difficult it is to describe molecular amplification in a single paragraph. I think I used two paragraphs in different places, but then to a certain extent I repeat it slightly to get it down to its simplest level and yet still be accurate. So maybe I'll try. I'm doing it off the top of my head now, and I haven't got words in front of me to shuffle around. But essentially, this is in fact, it's what's topical at the moment. All over the world, this stuff is being done on samples from members of the public who are being tested for evidence of infection with the coronavirus.
That's right. Every time we go out and I've probably had 20 coronavirus tests via PCR in the last 9 months. And maybe that's more than the average person, but very few people at this point will not have had PCR touch their life. So whether it's a coronavirus test or a crime scene that is trying to demonstrate if that microscopic drop of blood is from a suspect, it would go through this amazing technology for which the Nobel Prize was awarded in the 1980s to Kary Mullis.
Yeah. So, and something that isn't in the book, I don't think, I'm not sure it's in the book, is that partly it begins with the discovery of a polymerase in the Yellowstone National Park. Now, you can say, what's a polymerase? Tell me what a polymerase is, just to shorten it a bit.
So it's an enzyme, basically, that catalyzes a reaction. So, I mean, I can even shorten a bit of this whole thing for you, right? Which is when you have a double strand of DNA, how does DNA replicate? So there are basically two reactions that you want to be able to do with DNA. Sometimes you want to just make more of it. So for when a cell is dividing to make another version of itself, it has to break apart that double strand of DNA, and it has to make another template of each of it. And it uses enzymes to do the breaking apart and then the building. And there's a code for DNA. It's a very simple code because there are 4 letters, and each letter has a known corresponding letter. So you have these you have this code where you basically break it apart, you replicate it, and then you duplicate the strand. There's another side of breaking apart DNA, which is if you want to make protein. And here you actually break it apart to make a single strand of something called messenger RNA. And the RNA carries that message out to be transcribed as a protein. So it depends on the application in which you're doing it, but these polymerase enzymes basically facilitate different aspects of this process.
So like the evening news, I'll do a little bit, maybe on that. So yes, so there's this ladder joined together, and this is the classic double helix of DNA, and so we'll do the machine version because that's what we do. These days, this is all automated. Not so long ago, not so many decades ago, this was all done manually, very time-consuming, extremely boring process. Now done by machine. And the machine heats up the test tubes with your samples in and a few other things, controls and what have you. And as it heats up with these things, the ladders split apart. So that instead of having something joined together, you've got them separate. And in the case of measles virus, you have something, a preliminary step called reverse transcription, where because the virus RNA is a single strand rather than DNA, which is a double strand. RNA, ribonucleic acid, is a single strand. So for this technology to work, you need 2 strands for reasons which I'm sure you'll probably get to. So what happens initially is a second strand is created synthetically, so that you then have what is called cDNA, which is a kind of an artificial construct of DNA. And then once that's done, won't go into how it's done, but once that's done and you've then got this piece of DNA, the machine heats up the material, the test tubes in it, and these two ladders split apart. And at that point, this polymerase, this enzyme that amazingly was discovered in the Yellowstone National Park, goes along the broken rungs of this ladder and creates a complementary second ladder. So for each of the points, rungs on the ladder, it creates another one which joins to it. And these are the nucleotides that, the base nucleotides, the fundamental building blocks of life. And so when you start off with these these split apart, the polymerase runs along from one end of the it's unbelievable, really, runs along from one end of the ladder to the other, and then you've got two DNA, two double-stranded samples. So then you cool it. The cooling brings these two together and they solidify. And then you repeat the procedure. They split apart again. The Taq polymerase goes along and creates the extra thing. And then instead of two, you've got four. And then you cool it down. As you cool it down, then you heat it up again. And you keep repeating this process until two becomes four, four becomes eight, eight becomes 64, is it?
16. Yeah, it goes exponentially.
Yeah, 60, and on you go until ultimately
2 powers. Yeah.
Yeah, before very long,
it becomes astronomical,
unbelievable numbers, and then at that point, you can read it, and it's read by things called primers and probes. What primers do, these are other little bits of nucleotides in a chemical solution, which bind to very specific nucleotides. They're like bookends. So you've got these primers which take a slice, essentially mark out a slice, and this other thing comes along and identifies, called a probe. And if the thing that you're looking for is present, the whole thing by magic, which is now all being monitored by laser beam, which is like taking samples, measurements by millisecond as to while this is going on, will give a signal, which is then recorded on a computer and generates a curve. And this curve, it starts off flat and then it rises and then it goes, what's the word? It
asymptotes into a flat.
It's kind of a rough kind of S shape. And before it asymptotes, goes flat, you take a reading. And that's usually at about 35 cycles.
Right. And that's, to put that in perspective, that means 2 to the 35 copies you've potentially made. And, by the time I was doing this, it had become so automated. The kit was called TaqMan, like TAQ, because of the polymerase you mentioned, the Taq polymerase. And so it was called, real-time quantified PCR.
Quantitative.
And it was really quite amazing because as the scientist, you only had to prepare the reagent, and it was literally as simple as a Betty Crocker cooking exercise where you put in your primers, you put in your probes, you put in your Taq, you put in your sample, and the machine would go through everything you just said, the heating, cooling cycles, and it would spit out for you the information of what's present and how much of it is present. Because remember, you can go up to 35 cycles, but if you start with a large amount of nuclear material, you'll see it much sooner. And in fact, even with the coronavirus, that's an important feature, right? So when a patient tests positive via PCR, you have to remember these tests are really geared for their negative predictive value more than their positive predictive value. You would like it if a lab would report how many cycles were necessary to demonstrate a positive test. And in a clinical assay, we're going to come to why all of this is relevant. In a clinical assay, you need to be able to report the number of cycles, because it matters if it was positive after 20 cycles versus 30 cycles. That's a far greater, that's a very big resolution difference in something being present. So I think you did a fantastic job, by the way, explaining PCR.
No, I think it's going to be all kinds of people like listening to this who are going to go, oh no, no, it's not, no, it's not.
Yeah. So let's now go back to O'Leary's lab. So the way you describe it, it's like he was basically paid to find something.
Yeah. Yeah.
So O'Leary has now sent the samples, the ileocecal biopsies of these children, and he has what at the time is a state-of-the-art machine, right? The ABI Prism 7700.
Yeah, I guess at the time, yeah.
And as you said, this is a machine that is not rated for a clinical diagnosis, correct? It does not have a CLIA. Yeah, it does not have a CLIA certification. One cannot make clinical diagnoses with it. It is a research tool only. And the company that makes it says, what? If you go more than 35 cycles, what is the inference of what you're looking at?
Basically, and in fact, Tony Fauci said the same thing. He did a video just a couple of months ago where he was talking about cycles, and he came up with 35 as well. Basically, once you go past 35, where the rising line asymptotes basically goes flat, then you're going to be getting, if you get at that point, if you haven't found what you're looking for, then you either conclude it's not there, or you've done something wrong and you need to start again. I mean, you said how simple this thing appears to be, and it's interesting that you would see it that way. In fact, the apparent simplicity is beguiling and misleading, because
it wasn't this simple in 1998.
No,
and furthermore, you can still be fooled by the machine an awful lot.
Yeah, the technology is so sensitive. I mean, it's in many ways it's reason why it's. I mean, we're probably into 2001 or something by now, but one of the reasons why it's a research tool and not a clinical instrument was because so much goes wrong, and the technology is so sensitive that just anything will create contamination. And if you're getting signals after 35 and you think they're positive signals, it's probably contamination or some kind of error you've made in the thing.
And even with the coronavirus, the test, so now we're dealing with a couple things that are different. One, you're dealing with a clinical grade PCR assay. So that means it is under far greater regulatory scrutiny, and it is far more standardized than anything that, someone like O'Leary was using. Secondly, even under those conditions, the test is far better at demonstrating something is negative than positive. So we say it has much greater negative predictive value. So when the test comes back negative, you can almost with certainty, more than 99% certainty, say it's truly negative. When it comes back positive, you really don't know that it's positive. You have to repeat the test. And any physician listening to this or patient listening to this who's had either themselves or a patient with a positive PCR for COVID realizes the first thing you do if they're not symptomatic is test again. And even in my practice, we've seen 3 false positives on PCR that were later found to not be positive. And that's just the nature of using a test that is so sensitive.
Mm. So anyway, O'Leary was this man, John O'Leary, was hired by Wakefield using, on Wakefield's recommendation. He was actually hired by Richard Barr, the lawyer that was working with Wakefield, to test these samples on these children with developmental issues, mostly autism, from the Royal Free Hospital. And O'Leary found, or at least, this is again where you get use of words is very important. I won't say he found, he reported measles virus in pretty much, 9 out of 10 children. And this created huge interest. They published a paper, and this was apparently the evidence that the measles virus was there in the guts of these children. But then you get to the question of, well, if they really did find measles, where was it from? Was it from one of these three things I was talking earlier on? Was it from nature? Was it from a natural viral infection picked up from somebody? Was it from the MMR vaccine? Or was it a laboratory strain? Because laboratories who work in these areas will often have, and in fact they have usually have a special room where these materials are prepared, called the plasmid room, where they prepare samples of laboratory strain virus in the case of measles. So there would be within this laboratory situation of O'Leary's, there would be laboratory strain virus being used and manipulated on the premises. So then the question would be, okay, he says he's found measles virus. Well, you sequence it. So in addition to this particular, the PCR machine that does this process, and you can say, well, okay, there's an element of identifying a sequence there because your primers and probes, these things that bookend and then lock onto the samples nucleotides, would do so more effectively if what you were looking for was there. But nevertheless, there's a second machine, a sequencer. These days they're called capillary sequencers, and they literally run the individual nucleotides, these minusculely tiny things which are contained, coiled up in the DNA of every cell in your body, and they string it all out and run them past laser beams, and they will identify each and every one of those nucleotides and mark out for you what it is. What are the four nucleotides? Do you want to do the four bases? Because
I think we can spare people, but A, T, C, and G would be their acronyms. Yeah.
And it's slightly different with
RNA. You substitute in U, but yeah.
Yeah, but so there's a machine, and O'Leary had one of these machines in his lab, and in fact he was invited to give evidence to with Wakefield sitting next to him. O'Leary represented himself as being an independent researcher, and in fact he was in a business deal with the guy sitting next to him, Andrew Wakefield. They had actually got a whole raft of business plans and joint ventures and money go rounds, and directors of each other's companies and all this kind of stuff. And he actually said into the congressional committee that he had one of these sequencers. He identified it, gave the make and what have you, in his lab. And so did O'Leary's lab produce the sequences to answer that question? Was it a virus from nature? Was it a virus from the MMR? Or was it a virus from the laboratory? And he never, ever produced any sequence data from those children at all. So this is why the book has this process described in it, and why we're talking about it in such detail now, because it's important that people understand what that means to not ultimately sequence your samples, to read that code that can definitively fingerprint the virus, where it's from. And if it was from a vaccine, then which vaccine? Was it from a vaccine from this company or that company or whatever? And he never produced any sequences. And when it ultimately came to the lawsuit that was launched in the United Kingdom, Andrew Wakefield's paper was published in February. The lawsuit was approved to go, and was the first writs were served, the first legal papers were served on the defendant drug companies the following October. Finally, when it came to the crunch, and a lawsuit which consumed, in today's money, roughly $100 million between the two parties, by which this lawyer, Richard Barr, in a duel with the drug companies, fought out in preliminary papers and what have you. The case never came to trial because it collapsed. They never, ever produced any sequence data from these children, notwithstanding the fact that by this time, thousands upon thousands of families in Britain, the United States, and increasingly around the world had been told that the measles virus had been found in these children and it was from the MMR vaccine. And that data has never been produced. And that, to me, is the most extraordinary indictment of these people. Not only the fact that these children in the Wakefield 1998 paper were a pre-selected group of children from parents who'd come to the hospital to make the allegation that their child had been injured by the vaccine, and hence to join the lawsuit that Richard Barr was preparing and Andrew Wakefield was working on. None of this was known. None of this was reported until a Sunday Times investigation by yours truly went into it at enormous cost in terms of my time. And then we had a big medical board hearing that disclosed information and disclosed the children's records or what have you. So there was that. And then there was O'Leary paper where again, there was nothing that revealed that this whole project had basically gone after something that was a complete illusion. I would describe it as a scam. And I would say that the only reason these people aren't under arrest is because they say and can say, oh, I believe that the MMR vaccine caused autism, which to me, in my opinion, I'm giving you my opinion now, in my opinion, that's just like the mafia saying, we're the good people. We're the good people. We think that we're protecting our clients. These people refused to sequence the samples in the PCR. They did not disclose who these parents were and why they'd come to the hospital to make these allegations. And by the interplay between these two events, the Wakefield paper and the O'Leary work, they were able to manufacture the belief that the MMR vaccine causes autism. And the consequence of that is that there are tens of thousands, probably hundreds of thousands of families around the world today who've been led to believe that their child that they've got with developmentally challenged kids, that their child was injured as a result of the parents' own decision to vaccinate them. And these people, and why this is so important, these people provide much of the backbone for the anti-vaccine movement today, which is running the websites and the Facebook pages and the YouTube channels, pumping out all this stuff now about the coronavirus. Up until December of 2019 and January and February of 2020, that was all about vaccines and autism and the MMR and all that kind of stuff. When the great switch came over to the pandemic we see today, that network, that infrastructure of parents who are torturing themselves with this idea that it might be their own fault for vaccinating their child, that their child has some kind of developmental issue, have become mobilized in the belief that they need to identify an alternative culprit to themselves. Now, I don't believe for a minute that these parents are in any way culpable for their children's autism, but these parents have learned to deflect and project onto others, the drug industry, me, governments, whoever, who they say are involved in this conspiracy to what they now call the plandemic, this conspiracy to promote vaccines and so on and so forth.
But before we get to that, there are a few other things I want to go back to that I also think are technically important to understand. Can you talk a little bit about the formalin stained samples in O'Leary's lab? Because I think that in addition to the failure to do strain-specific sequencing, which was the absolute mandate of this research, right? This was the purpose of the study. So in addition to failing to do this one thing you set out to do, when you look at the formalin staining, it, to me, is one of the most revealing parts of how contaminated this work was. Do you want to give people a sense of what that found?
Yeah. Well, okay. So if we go back to the Royal Free endoscopy suite, and these children being scoped, as they call it, when the they go into the small intestine. Um, they would bring out these samples, these pieces of tissue, and they were divided and went in two directions. One direction went to Wakefield's own researcher, scientific researcher, a guy called Nick Chadwick. He's actually left science now because I think in part because he became so disillusioned after this whole farrago. He went off and froze his tissues in liquid nitrogen. So they were frozen, just like frozen peas, which preserves the DNA, or in fact the RNA and of the sample and the RNA of the virus, were there to be any there, but there wasn't. But anyway, would have preserved the virus, but in pristine, deep frozen form. And then there was another set of samples split from this set that went to the hospital's pathology unit, and for what is a routine process in it's called histopathology in hospitals, where pathologists look down a microscope at samples which they stain with chemicals, and you get various reactions that they're looking for. So this second set of samples is fixed in formalin. And I think everybody knows what formalin is, a preservative. And the thing about when you preserve things in formalin is it tends to slightly scramble, or at least make less accessible, the the nucleic acid in the samples. So when you come to run a PCR test, you have to run more cycles to get to the same result. So if you split a biopsy and you froze this sample and you used the other sample you preserved it in the other sample in formalin and ran the machine, you would find the virus much quicker in the frozen one than you would in the formalin fixed one. And because
right, so just to go back to what we were talking about, that means if you take the exact same piece of tissue, you cut it in half, one goes in formalin, one goes in nitrogen. Let's say the nitrogen one hits its PCR threshold in 20 cycles. You might expect the formalin one to require 30 cycles to reach the same amount of genetic material, because you functionally started with so much less because the formalin had degraded it.
Yes, great.
So what happened in O'Leary's lab?
We should be doing, we should have a show on CNN and we could bat it back. Yes. So the thing about this, and the only reason this ever came out, and you see, that's another thing I have to say about my work, is it's less to do with vaccines and promoting vaccines or anything like that, which is not really part of my agenda. It's the scientific questions going on behind all of that, which are applicable to all sorts of it's much bigger than just vaccines. So what happened was they came up against, because the particular importance of the vaccine program, and they were suing vaccine manufacturers, they came up against the pharmaceutical industry. Pharmaceutical industry, effectively unlimited money. They can pay for anything, any kind of legal, scientific test whatsoever. Came up against the pharmaceutical industry, who hired Britain's top expert on the PCR technology. So they hired him, and he produced reports which which made the comparisons, among many other things, made the comparisons between the number of cycles on the fresh frozen biopsies and the formalin fixed biopsies, and found, and they were compared with it gets very complicated. They were compared with another gene. And essentially what he found was that it took the same number of cycles to get the same number of cycles on both samples, on both the formalin fixed and the fresh frozen samples.
To which there's only one explanation.
Which is that the virus got into the samples after they were fixed in formalin.
In other words, they could not have come out of the children. So the most gracious explanation is that this was purely a laboratory contamination. A less gracious interpretation is that it was deliberately falsified.
Well, this PCR expert, he went a stage further, a man named Steve Bustin, and he went a stage further because he was paid an enormous amounts of money to do this. I'm not saying he got paid too much money, because you pay what you get, what you pay for. He then went further and started looking at the individual wells, because this machine would have a whole rack of wells. I think there are, from the top of my
96.
They're 96, yeah. So you have 96 wells in a tray, which goes into the machine, and some of these wells would have the samples you're testing for. Some would have positive measles controls taken using a laboratory strain of measles, would be in some other ones. Some would have distilled water, and some would be empty. And he found that by analysing, and these wells are being monitored second by second by second by second by the machine, and all this data that's spewing out of the machine, I think hundreds of data points for each well, if not thousands, I can't remember off the top of my head, for each well, all this material was gathered, and O'Leary was very keen to avoid it being disclosed to the drug companies who were demanding. In fact, ultimately, the drug companies' lawyers had to go to the High Court in London, who then made an application to the Irish High Court to order O'Leary to produce the data, to produce the outputs from this machine. And he came up with all kinds of reasons why he couldn't. He was in Australia, the machine broke down, the dog ate his homework, and on it went. But ultimately, this guy Bustin did get data, and he found that wells that had been reported by the machine to be positive for measles virus were in fact submitted in legal papers as being an empty well, as having nothing there, as though somebody had taken an eraser and rubbed out the result. In other cases, he found that wells that were themselves empty were reported positive and rubbed out. And so there, in his analysis, there had been manual human intervention to adjust the results coming out of those machines. That machine, in fact, well, there were two actually, but out of that machine, in order to make the results consistent with what Wakefield wanted to find. So the interpretation of that by many people, and I just simply observe it, was you would have to assume that a person or persons unknown had deliberately cleaned up the output of that machine.
Yeah, let's reflect on that for a second, right? So let's pretend we were talking about a company, say Enron, who had deliberately, with its accounting firm, manipulated its books in such a way that it could deceive shareholders. What would be the consequences of that? Well, in that example, the consequence is jail.
Well, I don't know what's happened with Volkswagen, because part of the Volkswagen group did precisely that with fuel emissions from their cars, where they rigged the results. I don't actually know how that one's played out yet. I don't know if anyone's gone to jail on that one, but you would think, yeah.
And so it's interesting when you look at this case, it really doesn't, if you just viewed it through the lens of the behavior, not the consequence, but the behavior, it's as nefarious as the most nefarious thing that we see in the stories of corporate greed and things like that, and certainly more than even the corporate incompetence that sometimes masquerades as greed. Another thing that I again, I don't want to just dwell on this beyond anything, but again, it's worth noting how when you finally got a hold of the medical records of those 12 kids, or at least a subset of them, they were not Which again, if you were looking at medical records of children that went back to when the events actually occurred, meaning when they were actually vaccinated, when their symptoms truly showed up, so before they were recruited into the study, how consistent were the true findings with what were ultimately reported? Were they? My recollection is they were not entirely congruent in that regard.
Oh, that was all bullshit. I mean, the we kind of skipped that one, but yeah, no, I was. What happened was that when I first broke the story in the Sunday Times, a series of pieces, and then I was invited to make a television documentary, an hour long. It's in the Dispatches Strand in the UK, and in the course of that, Wakefield then sued us using actually the medical profession's money at the time. He was still a doctor at the time, and he sued us. And because he sued us, but then he wanted to have his lawsuit frozen so that he didn't actually have to go ahead with it. So he was going around telling people he was suing us, but in fact, he'd had his suit stayed, as the legal word, to freeze these things. So me and the television company, Channel 4 Television, which is a national network with statutory duties for fairness and balance and accuracy, we took him to court and forced him to sue us. So he'd either have to put up or shut up. And in the course of that, I was able to read these children's medical records and get other documents disclosed to me, which are evidence to me that these children did not have what he said they had. There was not a single one of those 12 children whose cases were accurately reported in that paper in the Lancet in February 1998. Not one of them. There were children whose developmental issues preceded their vaccination. There were children whose issues were not 14 days or less after vaccination, but months, in some cases, many months later. In fact, what he called his sentinel case, the first parent who came to him, who phoned him at the suggestion of the Jackie Fletcher who'd set up the campaign group, the first patient, she ultimately admitted in court papers that her child had shown no issues associated with inflammatory bowel disease or autism or anything like that for 9 months after vaccination. And yet when she went to the hospital, she said 14 days. Was actually nothing before 9 months later. So, and then there were children who were reported in the paper as having a diagnosis, a behavioral diagnosis of autism, who didn't have autism at all. Didn't have an autism diagnosis at all. I can't say what people did or didn't have. I can only say I can't bring them back, and I can only say what the reporting said. They did not have autism diagnoses. So what Wakefield had done was to change the times to onset, change the diagnoses, and he was a non-clinical academic gastroenterologist, wasn't a clinician, had no patients, as I call him in the book, a doctor without patients, although some other doctors who don't have patients have taken issue with that. But he changed diagnoses. He represented as an inflammatory bowel disease, normal pathology findings, and there was nothing in that paper that could be reconciled with the actual children's diagnoses, records, histories, and laboratory and blood tests at all. Not one of them. And that really, I suppose, is what I was able to do. I mean, interestingly, because he sued us in the UK and then abandoned that. He actually abandoned it on the day I was sitting reading the medical records of the children at my lawyer's offices. I couldn't use that material because it was sealed material. I was seeing it as pursuant to court order. I was reading the children's medical records pursuant to a court order, which allowed me to do it. In fact, one of the parents turned up to court and challenged and said they shouldn't be allowed to read my child's medical records. It's confidential. And the judge said, well, I'm not having these parents saying who can have what documents, and gave an order for me to read the children's medical records. But I couldn't use it until what happened then was there was a huge medical board hearing, went on for 217 days, longer than the trial of O.J. Simpson, at which these medical records were studied and read aloud over and over and over by lawyers in London. And at the end of it, Wakefield lost his license to practice medicine, and the Lancet retracted the paper. So that medical board hearing, which was a reinvestigation of my findings in the Sunday Times, and really, as a newspaper, we forced them to do it. They had, and it cost. I think the ultimate figure was about £10 million to have this hearing. But I couldn't use that material until it was ventilated at that hearing, and other documents I couldn't use until Wakefield then sued me again in Texas when I did some reports for the British Medical Journal, because they asked me to do a series of reports for a medically qualified readership. So we did that, and then Wakefield sued on that. He was funded by a New York financier called Bernard Seltz and his wife Lisa, who put up the money, who ponied up the money for him to sue me and the British Medical Journal. And that was thrown out too. But in the course of that, the documents that were disclosed behind seal in the UK litigation was unsealed in the American litigation, and I was able to use it in my book, The Doctor Who Fooled the World. And that tells the story of all of this, and indeed a lot more.
There's one piece of this story, Brian, that I think I'd love for you to also tell, because it still comes up a lot to this day, and it's the story of, quote unquote, the CDC whistleblower.
Yeah, to be honest, Peter, I mean, I think I'm getting a bit tired now. I mean, we've been talking for more than 2 hours, and that's
a record for you. I know that's a record.
People want to know about the CDC whistleblower and this movie Vax that Wakefield came out of, and the rebirth of the anti-vaccine movement. Because by the time I'd finished this aspect of the investigation, Wakefield was finished. I mean, he had haircuts worse than mine. This is a COVID lockdown London haircut. You know, I haven't had my hair cut for, like, I don't know, 2 months or something, 3 months, God knows what. He was walking around looking like me now. Yeah. He was finished. He was written off. None of his colleagues would speak to him. He was done. But then came the return of Andrew Wakefield on the scene, and that's the next stage. That's the fourth part. The book is in 4 parts. The first part is big ideas. The second part is secret schemes. The third part is exposed, and the fourth part is avenged. And you then come to avenged. Wakefield's what I would characterize as a vindictive riposte to his personal ruin, where he started to do what he's always done, which is to mirror his own behavior onto others and accuse or falsely claim that a researcher at the CDC had accused his colleagues of fraud, and that Wakefield had discovered with this fraud through this alleged whistleblower, and that wasn't true either. But I mean,
let's give people a chance. They'll read the book. You do a very good job describing this with full transcripts. And again, I think it's important for people to understand this. Do you think that Andrew Wakefield would ever sit down with me for an interview?
No. He will only sit down for an interview with somebody he knows will not ask him questions that are difficult. That's the first thing. And secondly, you would not be able to field his replies. So, for example, he will say, and he does say, I never got involved in the lawsuit until after the children were seen at the hospital, which is just a most flagrant lie. I mean, I've got the paperwork, I've got the contract, I've got the right.
He was involved 2 years before.
Yeah, but he will just lie to you. I'm just giving you really obvious.
So you're talking, the degree of pathologic lying is so great that it becomes you're in a fact-free zone. I want to end on two things. The first is I want to read you something from the New England Journal of Medicine, which in 2011 wrote an article, or published an article rather, titled "The Age-Old Struggle Against Anti-Vaccinationists." I'm going to read you a quote from it, and I want you to tell me if you think this is accurate or if you think this is too harsh. So it states that this has been an issue that's existed since the 19th century, but now the anti-vaccinationist media of choice are typically television and the internet, including social media outlets, which are used to sway public opinion and distract attention from scientific evidence. The editorial goes on to characterize such people as they tend toward complete mistrust of government and manufacturers, conspiratorial thinking, denialism, low cognitive complexity in thinking patterns, reasoning flaws, and a habit of substituting emotional anecdotes for data, including people who range from those unable to understand and incorporate the concepts of risk and probability into science-grounded decision-making, and those who use, presumably on the other side, deliberate mistruths, intimidation, falsified data, and even the threats of violence. Do you think that's too harsh?
I think that's absolutely right. What I would say about it, now that's absolutely right. But what I would say about it, that is static prose exposition. Yeah. Now that's one way where somebody could say, well, I don't know who wrote that, but whoever it is probably a very learned person with enormous experience. I'm telling you this. That's what he's doing. I'm telling you this in the New England Journal of Medicine. What I've tried to do is to take a different approach to it, which is to tell the story and to show people, which is why we got into all that stuff about cycles of PCR and things like that, is to show people the real characters behind this and the specific facts of how they did it. And that's what I tried to do in the Doctor Who Fooled the World, is to tell the story as a narrative. Who did what? And the closing point from me would be a quote from my own book, I suppose, if I can remember it, is, and this is before the pandemic began, I wrote this, was that to me the importance of it was not just about vaccines and vaccine safety and the issues that you deal with in your clinical practice, but it's this: if he could do what he did, and I show you what he did, who else is doing what in the hospitals and laboratories that we may one day look to for our lives? Now, we are looking to those hospitals and laboratories for our lives. And that's really the message behind the whole thing. It's not, I had no message to convince people to vaccinate their children. I don't advise people to vaccinate their children. I don't accept endorsements of my book from vaccine manufacturers or the usual suspects whose names we all know. I was interested in that question. If he could do what he did, who else is doing what in the hospitals and laboratories that we may one day look to for our lives? And that's the importance of it, because the reason Wakefield got caught was because he took something as high profile as vaccination, affecting everybody's children, subject of primary concern to almost everybody. And he chose to do what he did within that. So therefore, I was able to, for my very first story, I got 4 months to investigate before we published a single story. I had the television program that I think we're about 8 months or 9 months preparing that. The BMJ series, which took 6 months to prepare for publication. The book, and all of this is subject to the scrutiny of lawyers, other journalists. My contract with Johns Hopkins University, my North American publishers, requires that I've told the truth. And if I hadn't told the truth, my publishers would be in a position to pulp the book and send me the bill. That is the contractual position I'm in. The book has been reviewed, but it's been peer reviewed. 2 different libel lawyers, one in New York and one in London, have looked at it. And 2 members of staff at the Johns Hopkins University Press went through all my documents against 2,000 references, footnoted references in the manuscript of this book, to be sure that what I've been saying is backed by the evidence. It's not just me saying it. So while I appreciate those words from handed down by somebody who knows about these things and summarizes it based on their expertise and their life story themselves, what I've tried to do is to tell the story of the real people and the specific facts as to how we got the anti-vaccine movement that is today causing all this mischief over SARS-CoV-2 shots. So that's my pitch, and that's why I wrote the book, and I hope somebody might go out and buy it.
I think people absolutely will, and I think that people should not assume that because they've heard this podcast they know all that's in the book. The book is incredibly rich with detail. As I said at the outset, I read the book twice because it's a book that you can easily miss parts the first time through. I think my closing thought, Brian, will be this. First, I guess I have two. One, I really appreciate the point you just made, which is this is really less a book about vaccines, and it's more a book about how science can go wrong and how science can be corrupted by bad people. And I think we can say that. I think for me, a very sad footnote to this story, which you've alluded to, begins with the kernel of those 12 children who were summarily tortured in a hospital some 20 years ago. And if anybody listening to this has a 6 or 7 year old child, and especially if any parent listening to this has a child with autism, they will understand what you said, which is these are children in whom any deviation from a normal routine is devastating. That means bedtime being at a slightly different time. Never mind going to a hospital, sleeping in a foreign place, being tortured through a bowel preparation when you're constipated, having a colonoscope rammed into your colon, one child having 12 perforations, if my memory serves me correctly, having a lumbar puncture, multiple venous punctures, to then realize all of this was done without even a modicum of investigational review board oversight. In other words, this was not even deemed an ethical thing to do. To think that that's the kernel of evil that then went on to produce so much angst for so many parents who now are left wondering, have I done something to cause harm to my child? I think that is the absolute saddest legacy of this. And despite if effective tomorrow, if this story vanished, which it won't, there would be no undoing what I consider that unspeakable harm. So I thank you for doing what you've done. I wish we could end on a happier note. And I thank you for staying up so late. I know it's very late there in London, but I'm greatly appreciative for this time, Brian.
No problem. Thanks, Peter. Thanks for your interest.
Thank you for listening to this week's episode of The Drive. If you're interested in diving deeper into any topics we discuss, we've created a membership program that allows us to bring you more in-depth, exclusive content without relying on paid ads. It's our goal to ensure members get back much more than the price of the subscription. Now, to that end, membership benefits include a bunch of things. 1, totally kick-ass comprehensive podcast show notes that detail every topic, paper, person, thing we discuss on each episode. The word on the street is nobody's show notes rival these. Monthly AMA episodes or Ask Me Anything episodes, hearing these episodes completely. Access to our private podcast feed that allows you to hear everything without having to listen to spiels like this. The Qualies, which are a super short podcast that we release every Tuesday through Friday, highlighting the best questions, topics, and tactics discussed on previous episodes of The Drive. This is a great way to catch up on previous episodes without having to go back and necessarily listen to everyone. Steep discounts on products that I believe in, but for which I'm not getting paid to endorse. And a whole bunch of other benefits that we continue to trickle in as time goes on. If you want to learn more and access these member-only benefits, you can head over to peterattiamd.com/subscribe. You can find me on Twitter, Instagram, and Facebook, all with the ID Peter Attia MD. You can also leave us a review on Apple Podcasts or whatever podcast player you listen on. This podcast is for general informational purposes only and does not constitute the practice of medicine, nursing, or other professional healthcare services, including the giving of medical advice. No doctor-patient relationship is formed. The use of this information and the materials linked to this podcast is at the user's own risk. The content on this podcast is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Users should not disregard or delay in obtaining medical advice from any medical condition they have, and they should seek the assistance of their healthcare professionals for any such conditions. Finally, I take conflicts of interest very seriously. For all of my disclosures and the companies I invest in or advise, please visit peteratiamd.com/about, where I keep an up-to-date and active list of such companies.